All right, I'm Anthony Noyes. This is our demo for Lab 1 for CSCE 462.
And I'm Nathan Magberger, also Anthony's partner.
So the system requirements we have listed right here are: when the button has not been pressed, traffic light 2 stays green. That's the traffic light for the cars. When the button is pressed, the car's traffic light will indicate that the button has been pressed by the blue light blinking and then turning red. When the car traffic light turns red, the crosswalk becomes green and the countdown starts counting down from 9 to 0. When the countdown reaches 4, the pedestrian crosswalk warns the pedestrians by flashing blue. When the countdown reaches 0, the pedestrian crosswalk becomes red, the car's traffic light turns green, and once the button is pressed, there's a 20-second cooldown to be able to make another valid press. So this is essentially just designing your average crosswalk where there's a lot of traffic, but every once in a while a pedestrian might come along and need to cross the road. So we'll look at the circuit we wired up here. So right here we have our Raspberry Pi with some relay cables and then a whole mess of wires. I'll see if I can get a good shot. So most of these wires we have coming out of here are just for GPIO usage. Either reading inputs or providing outputs to the circuit. A couple of them, like we have a 3.3 volt power supply and a ground as well, so that the LEDs have power. So first we'll go over that button that we have hooked up there. That's going to be our pedestrian's button to press. We have a resistor coming off of, let's see, looks like that's our input. So we have an input voltage right here going across a resistor to the button, and then the other side of the button is has a pull down resistor, so that way that the input does not bounce around. So once the button is pressed, one of the GPIO pins will detect it and start the sequence. And here's our car's traffic light. Here's our pedestrian's traffic light. Both of those have resistors connected to ground. And then here's our countdown timer, which will count from 9 to 0. All of these segments individually connected to GPIO pins. So now we'll go over the code.
So for the first part of this code, we are initializing the set of pins to be outputs. So, and then right here we have specific variables for these pins because they will go towards the 7 segment display. And then over here for P1 and P2, we have them set to 33 and 7, which are the pins for the red lights. And we want to average these out to 2 volts. So we have a PWM of 60% for both of them. So it'll be 60% high and 40% low, and that'll average out to 2 volts. So for this section of the code, we are basically setting the initial state of the circuit. So we have red light 1 on, or red light and green light 2 on as well, and everything else is set to low. And then for this line 156, we are setting up the input pin when the button is pressed downwards. So here for the polling method, this is basically a forever loop, and this recognizes if the button is pressed or not. And then for the interrupt method, this also detects if the button is pressed, and it will call the crosswalk function. And basically for the interrupt method, it essentially queues up the next one while the polling method doesn't. So you'd have to press this again for the polling method, you'd have to press the button again after it's done executing. But for the interrupt, if you press the button again while it's executing, it'll queue that up basically. So for the crosswalk function, if we go all the way up here, so when the button is pressed, the green light 2 will turn off and the blue light will start blinking, and this will happen 3 times. So it'll go high, low 3 times, and there will be sleep functions in between. And then once that's done, red light 2 will turn off, or red light 2 will turn on, and which is the traffic light, and red light 1 will turn off, and the green light 1 will turn on. So this signals to the pedestrians that they can cross, and there will be a countdown that goes from 9 to 0 on the 7-segment display. And there's a sleep function in between for each one to signify a second counting down. Now, when it hits number 3, a blue light will begin flashing as a warning to the pedestrians that your time is almost up to cross. So the blue light will keep flashing, and then once it hits 0, the blue light will stop flashing and the red light will turn on, signaling to the pedestrians that you can't cross, and then the green light will turn on for the cars to keep on going. Now, once this is all done, the program will sleep for 20 seconds, meaning that the cars will keep on flowing for 20 seconds and the pedestrians cannot cross for those 20 seconds. So this is a safety mechanism, or it's an insurance for the cars that they will have an allotted amount of time to keep the traffic flowing.
And we can actually go ahead and demo this right now. So right now we're set up on the interrupt method. So we'll go ahead and press the button. So the cars are signaled that they are about to get a yellow, then the light turns green, countdown begins, pedestrians get their warning, and then once it hits 0, it goes back. And we can try and press the button again, and it does nothing, but with the interrupt method, it gets queued up. So after 20 seconds pass, the process will begin again. And do you want to queue up the polling method so we can run that next? So there you go, 20 seconds passed. The sequence will start again, all according to the system requirements that we were given in the lab. You can right click and comment it.
I didn't even know you did that. Oh wait, I just put another comment.
Oh, you have to do comment out, yeah.
Okay.
Type in the terminal so I can enter it. Okay, so we just finished running the interrupt method. So is the terminal cleared?
I think so.
I assume so. Okay, so go ahead and run it again. So now this is set up for the polling method. So we will run the sequence again. And of course the code is the same for the sequences. It's just how the button is.
But if we press during, it won't recognize any of these inputs.
Mm-hmm. And now that it's sleeping as well, we can press it as many times we want within that 20-second window, and the program will not run once the sleep is over. So we'll wait about 10 more seconds to show that. All right, so it's probably been about 20 seconds and the program is not running. It's just continually polling the pin for an input. So we're gonna provide it one and it runs again.
Perfect.